Welcome back to lesson 8 of the Java tutorial series, and today we're going to talk about access modifiers and method overloading. Again, I'm telling you, it's going to get pretty serious pretty quickly, and last class we talked about classes and objects. So, as advised, please go watch that one if you haven't, because this is basically no review, because we have a lot to cover today, and we have not much time. So yeah, I don't want to keep you for long. So that's why you watch the last video. Come back if you haven't. But if you have, great. We'll continue off. In fact, that's what we're gonna do right now. We're gonna continue off here, and we are going to take a look back at our car class here. So we have our class. Let's just delete this file. It doesn't make any sense. We don't have any difficulty here, but let's just delete this. Let's just delete this. Alright, so last class we talked about objects and classes, and I told you at the end of the last class, I said that public isn't recommended. Now you might you don't even know what public is, but today you will. So public, actually, in fact, there's a few of them. So these are access modifiers, and there are a few of them. So access modifiers: public, private, protected. So just like that, we have 3 access modifiers at our disposal here, and each one of them has their special purpose. So, for example, public. Public is a modifier that basically exposes the variable to everybody. So, also the part of the reason why I want you to define your classes in files is so that these access modifiers will make sense. So think about this file as a compartment. So everything that's labeled public, other files can see. That way it makes much more sense. So think about public class. So you want car, class car. Obviously, public class car, it has to be public because other files can see, our file. But you see the fields there. They're all public too. Now, why do we want private fields and not public fields? So let's step back for a second and let's talk about public fields. So everything again labeled public, you can see outside of this class or file. Let's just call it file because it's easier. So let's go back to main. Now, obviously, we can do my BMW dot mileage. So you can see we can access this because it's public. But if we change this, what was it? Mileage? Yeah, if we change this to private, you can see it no longer exists. Why? Because it's hiding it. So, private, let's see, private, yeah. Alright, and you can see that little red squiggly line underneath that says, I can't find that variable when you can actually find the variable and it's just hiding under here because it's private. So that, now you can kind of see why, what public and private means now. So that's why, again, place your classes in each file. So that way you can visualize this access modifiers better. So if you put everything inside one file, it might seem counterintuitive to have a private field inside, a class that has, it just doesn't make sense. But once you place it inside a file, you can see how it makes sense and how public and private exposes each, piece of data. So now, again, if we recommend, actually not just me, pretty much if you ask every Java developer what they recommend on this subject is that always have private fields and public methods. Well, obviously you're going to have public methods because how else will you access them? So we have public methods. Constructor must be public. Why? Because you're literally constructor and thing. Okay. But everything else here is private. So let us change this to private because it is for good practice. Again, you can see it doesn't require us to change it, but we should change it just because. Not just because here's the reason why. So private members can only be accessible, right, when they are declared using the public keyword. I mean private, sorry. But now why is that? So it's one thing, it's called encapsulation. So encapsulation, it keeps the class increasing from step by step. So it's basically you have like some APIs here, right? And then you want to encapsulate them just to make it abstract, so that when you are when when the other when other developers go to you, they don't have to see what fields you have, but they can at least access your public methods, and that's all they have to worry about. Because if you have a bunch of public fields, it gets messy, and it's not good. So basically, that's why you want to name it a private, because for example, data hiding are follow to help us programmers write code. So if any class, let's think about it. So if your class can change my field, then wouldn't that mess everything up? Yeah, it will. So let's, for example, we can redefine this field and we can change it. Now, you don't want to go in and mess around with this field, will you? So that is why you don't want to name it public. So what I'm trying to say, yeah. So all that fancy talk leads down to one thing. You don't want to change what happens in here. You only want to read from it, because that's what the purpose of the class is. The purpose of the class is so that you can create abstract methods and stuff, so that you can implement them in your main function. So by changing the fields, that defeats the purpose of the constructor, because the constructor is literally supposed to change it. So by declaring it private, you cannot change any field. So from main class, you can't access the private member, but in the card class, of course you can access it. It's your own house. I just think about that. If you want to name your field private, it's your own house. Your mailbox will be public. Why? Because other people can see it. So how will we get the mileage then? Well, it seems kind of redundant, but this ensures that no fields are overwritten. We just we just have to do it. We just have to do get speed, and you just have to do this. It seems unnecessary, but it ensures one thing. It ensures you can only read the speed, or we can do read speed and not write speed. Because if you write the speed, you can change it. I mean, you technically can change it by writing it up here, but this ensures that the logic wouldn't break, because everything will have to be accessed through the constructor. So just like that, you can get the speed, and we can do, for example, we can do public string get name, return this dot name. So next time when we do this, we don't really do this. We just do my BMW dot get name. That way you use the method to get the name, and you don't have to don't have to modify the field. This is especially true if you have final variables. For example, final, remember, we can't change it. So if you have a big project and you type on Eclipse and what public final appears, because Eclipse has autocomplete and stuff, you might like, okay, well, that should be normal, so let's just use it. But then you realize it's a final and it messes everything up. So that's why you want to have some functions, so that you can give them what they want through the function without having them to access the fields themselves. So that is why you should have private fields and public methods, because obviously, how are you going to access the fields? So that is basically private and public. Now, what the heck is protected? Now, protected has to do with their package. Because you can see, we're in this tutorial right now. Tutorial class package contains 2 classes. But, remember, in Java, there could be multiple packages. So, each package groups a certain amount of classes. So that's exactly what the protected keyword does. So protected, let's just do a final color. So protected final color equals green. Actually, we have to define the variable type. So protected final string color is green. Now, if we access it from the main class, you can see. Give me a second. Let me just put this back. Eclipse messed up on me. There we go. If we do this dot color, you can see that we can access it from this class. So it'll say green here, but yeah. So that's what protected is so that basically you have this package of classes here, right? You have car and main, but you don't really want other packages to see your thing. So it's kind of like a private for packages. So, you can interchange, because I guarantee you're gonna have multiple classes, and some of these classes might want to write each other with fields and stuff. So that's what protected does, so that you have this main class, it can look at this protected, but if we create another package and access this color, this variable color, then it wouldn't work. Because why? Again, protected is only for packages. So private, class only, protected, package only. So just think about that, and you'll be good to go. So now we are going to also talk about the static keyword, because look at here. Again, I promise I'll talk about it. Static keyword, nothing to do with access modifiers, but again, one of those things where don't really have anywhere to put it, so I'm just gonna put it with this. Isn't really worth it to make a video on some, but again, not access modifiers, completely different. Static modifier is a memory management tool. So basically, it allocates memory statically without giving them a dynamic interface. Now that seems like a lot, but what that means is that when you change this to static, you don't have to allocate new memory for it, aka you don't have to do this new car. So let us create a new class. So let's create a new class. Let's do new class here, and let's call it we can call it cat breeds. Actually, yeah, let's just do cat. So cat, and yeah. So obviously this isn't really a good example. You know what? I'm gonna rename it. So I'm gonna rename it to util. Give me a second. Whoop. Did not want that to happen. Alright. Util, rename the file, because from last class, remember the file has to be the same. Yeah. So now we have a util. Now we don't really want to create a utility object, because in here, I'll show you what goes in here. So, you just have the old stuff like add 1 plus 1. Right? This is pretty basic and utility. So that's pretty much what you want. And, you don't really want to create an object for this, because this doesn't really make any sense. But you still want to put it in a class, because utilities are really important. These contain, your random stuff, for example, like get random number, all of that good stuff, package it into utility. But why would you go through the pain of creating, an object just to access 1+1? It just doesn't make any sense. So we do one thing. We type public static int. Again, public static int. And now we don't have to create an object. I know, crazy. You can see no errors. Why? Because statically allocated, you don't have to create. You don't have to allocate new memory blocks. Again, no new constructors. Obviously, it'll print out too, but just to show that it works, and just to show that it doesn't work for the car object, so we can do we can do my BMW dot speed, right? But we can't do car dot speed. Why? Because remember, car is pretty much a template for you to use. A car, it's not static. There's no static methods in here. So we have to create a new object, allocating new memory so that we can have this object with car properties. So usually, again, for me, utility class, all static, because you just want to get the function as themselves and just return back the result. But for anything other than that, I recommend don't use static. So that is pretty much it for static. Of course, there's a few more things. We can have a static variable. Again, sort of like the same thing. We can have a static block. A static block is also a thing that can be executed once. Exactly once. So for example, we can have a static block outside of the main function and it'll get executed. What? Yeah, that's right. I just blew your mind today. You thought that only main function can run. But nope. You can, let's just do my speed. Actually, get speed. So that doesn't throw any errors. Oh, right. Duh. Not static. So, read speed, right? Alright. So we can do static system dot out dot print line hello, and you can see it's outside of the main function, but it still prints. What? Right? You're like, what? This isn't what you teach me in the first class, right? But that's just how it works, because remember, this main variable is allocated directly, so that when everything goes in here will be created in a new block of memory. But you can also add static keywords so that whatever is in here just runs once. Basically, memory gets allocated and then flushes the stream. Memory block gets deallocated or destroyed. New memory occupies it. So this hello variable, you see this car variable, or my BMW, if we're truly talking about memory here, this my BMW variable, it will get destroyed here. So the moment it gets destroyed here, so when the main function ends, it gets destroyed. But in the scope of this main function, everything works. But in static, if you have the static block, there isn't no variables, because again, everything runs exactly once. You can't really call anything. Statically allocated memory, again, run the thing that you put in here, allocate it, deallocate it, destroy the block instance, and then move on to the next. So that is the static keyword. So your friends might starting to learn Java, probably watching my tutorial series, but they start learning Java and they're like, the Hello World program, that's the shortest they can get. You have to type all this public static void crap, but you tell them, you're like, no, you can get even shorter. You just type static system.out.println, hello world. And your friends, trust me, it'll be amazed because people have said you can't do one-liner hello world programs in Java. Well, that is true because you have the public class main, but technically this is the closest you can get to a one-liner in Java, which is a static allocation of memory. So enough about static. Let's talk about function overloading. So function overloading, we're starting to get into the mindset of polymorphism here. So that's where we're trying to go with this, but basically in this car class, we have a bunch of unused. Oh, why did I move it down here? I don't know. Eclipse is being weird today. All right, so you can see we have some methods already, but we can. Did you know that Java has a feature where you can actually overload a method? Or basically, it's a fancy way of saying you have the same method with the same name. Process that in. So we have this method. For example, in fact, it's probably not a great idea to do it in a class. So let's go back to, let's just remove this. And boom. So that, okay. So it's not I'm just gonna demonstrate it inside this main class here. So right here, we can overload a method. For example, we can do add, right? Int A, int B. So pretty simple, pretty simple function here with the integer A and integer B. You just do return A plus B. So this is something I would have done probably way in the early episodes just to demonstrate how it works. In fact, I think I've done it before, but realize that you can duplicate this exactly, but changing the return type and the parameters. So we can do double. So now you have one function with two variants. So you can have an add function that can take in an integer or a double. And you can see Eclipse isn't throwing any errors because I have just overloaded this function. So, and Java the compiler will automatically pick up on which you specify by the parameters. That's why you have to change the parameters, because if they're the same parameters, there will be a problem because Java won't know which one of these you're asking because you're using the same parameters. So let's do add. For example, Java knows that this add function, right, static, of course, or else we have to create an object, and we don't want to do that. So right now, Java knows that this is the first variant, add, because it's 1 and 2 are both integers. So of course, when we run it, we will get 3. Now we can do 1.5 and 2.35. So again, normally if we didn't have this overloaded function, it will just return, well, let's see here, 1.5 plus, it will return 4. Now here's the reason why. Remember, it's automatically casting the double. Actually, you know what? It doesn't even return anything because it will just say error. 1.5 is not an integer. 2.5 is not an integer. But since we have this double here, you can see it returns 3.85. And it doesn't do lossy conversion. And it doesn't round down. So again, it truncates it. So if you don't have that decimal here, it will just return 3 because you're casting it to an integer. But with this, we can also do other stuff. So that is function overloading. You can see very, very useful. And yeah, because right now, again, if I remove this, let's just comment this out for a second. You can see it starts with an error. It says 1.5 is not an integer, right? Because it's a double. But what Java allows us is to have functions with the same name, but different parameters. I'll just put that up here. Different param type. That way, Java will know which is which. Because if you think about it, if we change this to integers, right? So we change this to integers, and then let's just do this. Java, we're gonna know which one to use. You can see duplicate method. So that's basically why the squiggly line is here. If you highlight on this, it says rename method because we have same parameters. So of course we will rename this to actually let's state this double and double. So again, params must change. And once we run it, we get 3 because Java detects, oh, okay, they're using the integer parameter version, which is up here. Add it, and boom, you get 3. So that is pretty much it for today's video. We talked about, access modifiers, static variable, and function overloading. So very, very important stuff. Builds off of the last video, of course. And yeah, so next time we'll probably talk about abstract interfaces, which is, I know, sounds complicated, but it's not. It's not. I promise you, it helps you with your classes. So yeah, so if you enjoyed this video, leave a like, smash that thumbs up, and subscribe, and I will see you in the next one.